Alrighty. We're gonna go ahead and finish up that 2.6 lecture. There's not much to it. I'm going to redraw the graph that I had in the previous example at the end of class. All right, so to go with this question as well, let's talk about if I ask you to find out what y equals g to the 1/2 x. Notice this time the multiple is inside the function. When this happens, and we take that table that we had originally down, well, let me rewrite that as well. So that would be -3, 0, -1, -2, 1, -2, and 3, 0. When we take this original thing, if you notice in the beforehand, when we had y equals 2 times g of x, we simply multiplied the y values by 2. So that gave us 0, -4, -4, and 0. When the number's inside, you're going to actually multiply the x value. So this time the y value will not change, but you're not going to multiply it by half. When it's inside, remember, if it's inside, it always does the opposite of what you think. If it's adding, it's going to the left. If it's subtracting, it's going to the right. Same concept here. If it's multiplying by a half, it's really multiplying by the reciprocal of that. So you're really going to multiply it by 2. So I'm going to take all of these numbers and I'm going to multiply it by 2. So that gives me -6, -2, 2, and 6. So when we want to regraph that, we can see that we'll go a little bit more stretched out here. And now we get a stretched out version of this graph, since we know that if it's less than 1, it's a vertical stretch. Oh, sorry, horizontal stretch. Right? And so I just want to note that this right here will actually be the reciprocal version of that. All right, so that'll conclude that question that we were last on. Let's move on to objective 4. Objective 4, we're going to apply the last part, which is the reflections across the x and y axis. All righty, so let's draw out a graph. All righty, let's see. So we'll have one here. All right, so there's our graph, just 3 dots. And we're going to figure out what y equals g of -x does and what y equals -g of x does. I tell you what, let me just do these in different colors so we can correlate correctly. So, yeah, that'll be y equals g of -x and y equals -g of x. So if we do the first one, the yellow one here, again, let's write our table. This looks like it was 0. This is x and y. Sorry. This would be 0, -1. This would be 2, -4. And this was 4, -1. And if I have the negative on the inside, I want to reflect that across the y-axis. So I want to reflect this the y-axis. And so to do that, I need to basically change all of these x values over here, but I don't want the y's to change. So what we're going to do is simply just multiply the x by negative. So my new one becomes 0, -2, -4. So when I graph it over here, I go 0, -1, which happens to still be there. Then I have -2, -4, which is now here. So that's the reflection of this point. And now I have -4, -1, which will be the reflection of this point. So this is my best drawing there, but that is the reflection if the negative's inside. If the negative's on the outside, then I'm affecting the y value. So I should be reflecting across the x-axis. So now that's an x and a y. We'll rewrite all our stuff. So this was 0, 2, 4, -1, -4, -1. But since the negative is on the outside, I'm going to affect the y so that I reflect it across the x-axis. So this is now a positive, positive, and positive. So now I'll graph 0, 1, which will be right here. And then I'll graph 2, 4, which would be located here. And then 4, 1. Then you can see that the red graph is now reflected across the x-axis on the green, and you can see that's reflected across the y-axis from red to yellow. All right, so that's basically what reflections will do. The last objective is now just putting it all together. So objective 5 is the summarize transformations of graphs. So in this first example, let's look at g of x equal to the square root of -x minus 4. Right? So that will be our first one. Things you need to note is that this is parent function here would just be g of x equal to the square root of x. So anytime you see a square root, that's the parent function. So what I like to do is I like to identify the parent function, and then I'm going to circle everything. You know, this looks really bad because it's all like really far away from each other. Let me redraw that if it lets me. That was again -x minus 4. All right, it's a little bit better. Anywho, so I'm going to circle everything that is different from this guy. So that negative is new and this -4 is new. That tells me I have two transformations happening. First one, I see a negative inside the function. Well, we just saw what happens when the negative is inside the function. It tells me it's a reflection across the y-axis. So that's the first thing I'm going to say. It's reflects across the y-axis. Then I see a -4 inside the function. So if it's inside the function, that tells me it's either going to go left or right. And if it's a minus, that tells me it shifts right 4 units. So don't forget that you have to say about how many. And that's it. It's all you have to do. Alrighty, so then when we move on to the next example, and I have g of x equals -1/3 x plus 2 squared plus 3. Okay, so I see the square, so that tells me that this parent function looks to be like it will be x squared. So that's one of the 8 parent functions I have. So I see that there's a negative, I see that there's a 1/3, I see that there's a +2, and I see that there's a +3. So that tells me there's 4 things going on. So the fact that there's a negative outside of the function tells me it reflects across the x-axis this time. I see that it has an A that's 1/3. Well, that tells us if it's outside, that tells me it's vertical. And if it's 1/3, that tells me it's a vertical shrink. Um, by a factor. Couldn't remember. By a factor of 1/3, because that's what it is there. And then we see we have a +2, so that means it's going to shift. And since it's plus, it does the opposite of what we think. So it's going to be shifts left 2 units. And the +3 means it's going to shift up 3 units. Right? Now, I just realized on your homework, it is going to make you graph this. So knowing that this graph right here does this, we're just going to shift that or use whatever the transformations are. So in this case, if it reflects across the y-axis, it's now going to go this way, and then it shifts up, or sorry, shifts right 4 units. So I'm going to take this center point, which is right here. I'm going to go right 4. 1, 2, 3, 4. There's my first point. And then after that, I'm just going to shift it. Now your homework is probably going to make you do like 4 points. If you know you're going in this direction, you got 1 point there, just plug the next point over. So plug in 3. So if we plug in actually, I think the way this is going to work, as I'm doing the math in my head, if I plug in -4, I get an unrealistic number. So I think it shifts right 4 and then reflects across that y-axis. So then I think I'm actually going to be over here going in this direction. So if I choose -5, -5 minus 4 is 1. That would be here. So that'd be the next point. Yeah. And as you can see, all I did to figure out that mistake there was I just plugged in -3 and realized I was going to get -7, which it happened. So what I can see is, well, I know it's going to be shifting right and reflecting. Maybe I'm shifting right first, then reflecting, because beforehand I reflect it and then shift it. So maybe the order matters there in some situations, not all situations, but in some it does. So if I do that extension there, I could do, see, that's 5. They give me 1. I'm going to want to do something nice looking. So let's try, if I do 6, that'd give me 2. If I do 7, that'd give me 3. If I do 8, -8 plugged in will give me +8 minus 4 will give me 2. So it'll give me another point about right there. And then if I want to try to get 9, I'm going to have to go to 13, because then that would be 13 minus 4, which is 9. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then that will give me 3, which will be about right here. And there you go. All right. Now you might be asking, how, George, you know 13? Because I know if I plug in a -13, 2 negatives make a positive, and 13 minus 4 gives me 9. My goal was to try to get nice, pretty numbers to come out so I can graph it. So again, I think y'all's homework wants y'all to come at least 4 points before graphing it. All right, so same concept here. I know that the quadratic makes a U-shaped. So that would be my starting. Ooh, that would be my starting graph. All right, so then after that, I think I'm going to do the reflection last, since that's what they did on the previous one. Let's see. So I'm going to go up to down. So if this is my first point, it's my vertex, I'm going to go left 2, and then I'm going to go up 3. All right, that's where I think the first point will be. I do see it shrunk by a factor of 1/3, so that just means my U would be a little bit smaller, but I also see its reflection across the x-axis, which tells me it's just going to go down. So really at this point, now that I got this point, I think I'm just going to plug in numbers that are close to it to kind of give me an idea. But since it's going by thirds, I think I might go 3 out so that my numbers might look good. I don't know. We'll see. Let's play this as 1 now. So we take the -1 and we get 1. And then 1 squared is 1. And then we get -1/3 plus 3. Yeah, that doesn't come out to a nice, pretty number. So let's try this. I'm going to go 3 numbers out, mainly because I know I'm going to have to divide by 3. Maybe they'll give me nice, clean numbers. That'd be 1, 2, 3. So that'd be 1. So that's 1, 2, 3. So that's the value of 1. So I plug in 1. 1 plus 2 is 3. 3 squared is 9. 9 times -1/3 is -3. -3 plus 3 is 0. So I get a nice clean number there. One thing to also note with quadratics is that they're symmetrical. So if I have a point here at basically 1, 2, 3 points down and 1, 2, and 3 points over, I'm going to have the same concept over here. So there's another point. So there's 3 right there. I don't know if you need a 4th one or not. If we do, we can do another one that will give me a 3rd. So maybe I try, let's see. So if I go 3 more over, where would that take me? If I go to 2, that'd be 4. If I go to 5, I guess, yeah, let's try that. So we'll go 3 more over. So that put us at 4. 4 plus 2 is 6. 6 squared is 36. 36 times -3 is -12. -12 plus 3 is -9. So that will put us round about right here. And then there should be 4 points there. And then knowing that it's symmetrical, I know I'll have another point about right there. All right. So when it comes to graphing, best thing to do is kind of just plug in some numbers after you've done your shifting and then kind of see what the stretching and shrinking is going to do. When it comes to me, I'm really just going to be noting, are you able to actually describe it? And then there might be some graphing, but be able to definitely do this and then be able to plug in numbers to be able to estimate where your graph should be. Other than that, that's really all that 2.6 talks about. And then I'll make a video for Wednesday so that we can analyze graphs of functions, basically just kind of tell us things about it and talk about piecewise functions. Other than that, I see y'all when I see y'all.